There are some good things which I would really commend you to look at very carefully. Very useful, very helpful. They will save embodied carbon and all those other good things. The first one is, if we've got a large area, let's say a large area supported by a particular member, will the load on that area be at the design value over the whole of the area? And that's extremely unlikely, of course. So there is a reduction due to area. Here is important because in these reduction factors, the UK generally doesn't accept the recommended reduction in the core Eurocode. So highlighted here, I say in the United Kingdom National Annex. And what we do is we replace the core Eurocode version with the version which we previously had in previous standards. So we're sticking to what we're familiar with and what we know. So there's a reduction due to area. And this one is ever so helpful. This is if we have a multi-story building, depending on the number of columns above the column that we're particularly designing, then there is a reduction factor. And again, it's a probability thing. Will all of the floors above our area of interest, will all of them be loaded up to their maximum design value all at the same time? Should we calculate the axial load based on that? Well, the truth is that's very unlikely indeed. So the more floors we have, the less likely it is that they are all loaded up to their full design value. So there is a reduction factor, which is incredibly helpful when you come to design the lower lengths of multi-story buildings. So here is a graphical representation of the reduction factor. And if you were working above, well, according to this, about 10, 11 stories, then the reduction factor is 50%. So you can imagine that will be a very significant reduction in the axial load that you would design your lower lengths of columns for in a multi-story building. So I would commend you to use that reduction factor.